The most dangerous moment in an AI agent project isn't when the code fails, it's when the Hello World demo works perfectly. In your local environment, the agent flows seamlessly, responding to queries with a sense of intelligence that seems almost magical. But the brutal reality strikes the moment you hit production traffic. Without rigorous state control, your agents begin to hallucinate in infinite loops, burning through thousands of dollars in API credits within minutes. You realize too late that the framework you chose was designed for a 30-second Twitter demo, not a 24/7 enterprise service. This gap between toy projects and robust systems is where most agentic initiatives go to die in 2026. We are seeing a massive graveyard of projects that prioritize ease of use over deterministic control. This failure often stems from a lack of checkpoints where an architect can intervene. By the end of this lecture, you will know exactly how to avoid becoming another statistic in that graveyard. In the eyes of an architect with decades of experience, production ready isn't about how fast you can write the code. It's about how predictably you can debug it. As we move into 2026, the criteria for choosing an AI agent framework have shifted from LLM abstraction to operational durability. You must ask, can this framework persist state across server restarts? Does it provide native observability for multi-turn reasoning? Can a human developer step in and override a decision mid-flight without crashing the session? If your answer is I have to build that manually, then you are using the wrong tool. Real-world systems require fine-grained control over the agent's thought process, not just a black box that spits out a result. These are the non-negotiable standards we must use to judge LangGraph, CrewAI, and AutoGen. But why do so many smart teams keep picking the wrong tools based on popularity? This is where the star trap becomes dangerous. Following GitHub stars is the quickest way to technical debt in the AI world. Remember the early days of AutoGPT? It captured the world's imagination with massive star counts, but when developers tried to build actual business logic with it, the lack of orchestration control made it nearly impossible to maintain. We saw a similar wave with LangChain's initial chains. They were perfect for linear tasks, but crumbled under the weight of complex, cyclic reasoning. The trend in 2026 shows a clear shift. Developers are moving away from magic frameworks that hide the prompt and moving toward explicit frameworks that give you the steering wheel. The tier list we are about to build isn't then based on who has the most stars, but on who survives the 3 a.m. production incident. To understand the future of these tools, we must look at how orchestration itself is fundamentally changing right now. The fundamental shift in 2026 is the transition from chains to graphs. In a simple chain, logic flows from A to B to C. This is great for data extraction, but real-world work is messy and requires loops. If an agent performs a task and the result is poor, it needs to go back to a previous step and try again. This is a cyclic graph. The problem is that most early frameworks were built as directed as cyclic graphs or DAGs, which strictly forbid loops. Forcing an agent into a linear path is like forcing a human to finish a report without ever being allowed to rewrite a paragraph. Modern frameworks like LangGraph have embraced this cyclic nature, allowing for self-correction and iterative refinement. However, cycles introduce a nightmare that linear chains never had to deal with, keeping track of what actually happened in each iteration. This is why state management has become the new battleground. In the architectural landscape of 2026, state management is no longer an optional feature. It is the very foundation of agentic reliability. When an agent performs a multi-step task that lasts several minutes or even hours, the probability of a network glitch or a model timeout approaches 100%. If your framework doesn't have built-in state persistence, you lose everything the moment a failure occurs. This is why checkpointing has become the #1 differentiator among top-tier frameworks. Advanced systems now allow for time travel debugging, where you can rewind the agent's state to a specific node, modify the context, and resume. This level of control is what separates a fragile script from a resilient enterprise agent. We need to look closely at how each framework handles this checkpointer pattern. Now that we understand the stakes of state and cycles, let's dive into the tier list of the top contenders currently fighting for dominance in 2026. In the world of professional systems architecture, LangGraph is often seen as the engineer's framework. It doesn't try to hide the complexity of state management. Instead, it exposes it as a first-class citizen using a directed acyclic graph or cyclic graph structure. By utilizing the state graph class, developers gain granular control over every node transition and edge condition. In 2026, as agentic workflows move from simple linear scripts to complex, multi-step reasoning cycles, this low-level control becomes a survival requirement. You aren't just letting an LLM hallucinate the next step, you are defining the exact boundaries of its execution. However, this control comes with a steep learning curve and significantly more boilerplate code compared to its rivals. You are essentially building a state machine where every state transition must be explicitly handled, which is great for debugging but demanding for rapid iteration. But wait, does this level of micromanagement actually lead to better performance, or are we just over-engineering our way into a maintenance nightmare? Let's see how the competition handles this differently. If LangGraph is the surgical scalpel, CrewAI is the heavy-duty multi-tool designed for orchestration. CrewAI operates on a high-level abstraction known as role-based multi-agent systems. You define a manager, a researcher, and a writer, giving each a specific backstory and goal. Under the hood, it uses a process-driven approach, either sequential, hierarchical, or consensual. This makes it incredibly fast to build a proof of concept that looks like a mini department of AI employees. However, experienced architects know that abstractions always leak. In CrewAI, when an agent gets stuck in a repetitive loop or fails to share a specific piece of context with its colleague, debugging becomes a nightmare because the underlying graph is hidden from you. By 2026, many teams are finding that the easy start with CrewAI leads to a hard finish when edge cases arise in production. What happens when these roles get stuck in an infinite loop of I agree without making progress? I'll show you exactly where the abstraction breaks down in the next scene. The fundamental tension in AI agent design for 2026 is control vs abstraction. LangGraph gives you the control. You own the graph, you manage the persistence, and you handle the errors. CrewAI gives you the abstraction. It manages the vibe of the collaboration and hides the complexity of prompt engineering for delegation. In a production environment, this choice dictates your long-term maintenance cost. If your agent logic is mostly deterministic with a few LLM calls, LangGraph's explicit nature prevents agentic drift. But if you are building an exploratory research tool where agents need to brainstorm, CrewAI's high-level roles save weeks of development time. The real battle, however, isn't about features, it's about who owns the state when things break. In LangGraphs, the state is a visible dictionary. In CrewAI, it's often buried in the internal memory of the crew. This distinction determines whether you can recover from a mid-process failure or if you have to restart the entire 2-pounder API call from scratch. This leads us to a critical question. Is there a middle ground that balances these two extremes? Let's look at how the tech giants are trying to solve this. Microsoft's AutoGen changed the game by focusing on conversation patterns. Instead of thinking about graphs or roles, AutoGen treats everything as a chat. Even a tool execution is just a message from a user proxy agent to an assist agent. This makes it incredibly flexible for multi-agent conversations where the path isn't known in advance. In the 2026 landscape, AutoGen 0.4 and beyond have introduced more robust asynchronous support and better state handling, moving away from the chaos of its early versions. However, the conversational abstraction can be misleading. In large-scale production, managing a chat history that grows exponentially with every agent turn becomes a massive context window and cost problem. You aren't just paying for the answer, you are paying for the agents to talk about the answer. Is your framework managing the agent, or is the agent managing your cloud bill? This overhead is exactly why some developers are looking back toward more native, vendor-specific solutions. OpenAI's Agents SDK represents the easy button. By keeping everything within the OpenAI ecosystem, you get native performance, optimized latency, and a simplified API. It removes the need for complex middleware and glue code that often plagues third-party frameworks. But as a system architect with decades of experience, I see a massive vendor lock-in warning sign flashing here. When you build your entire agent logic on a proprietary SDK, migrating to a more cost-effective local model like Llama 4 or a competitor like Claude 4 becomes a multi-month refactoring project. Surrendering your logic to a single provider feels good today for speed to market, but what about tomorrow's migration cost and the loss of architectural sovereignty? This trade-off is the single most common mistake I see technical leaders making today. But wait, there is a third path emerging, a minimalist approach that avoids both the bloat of heavy frameworks and the trap of vendor SDKs. In reaction to the complexity of LangChain and the rigidity of vendor SDKs, we've seen the rise of minimalist or lightweight frameworks like Mastra and Smolagents. These tools prioritize code over configuration. Instead of learning a proprietary DSL or complex graph objects, they encourage writing standard Python or TypeScript functions that the agent simply orchestrates. Mastra, for instance, focuses on the developer experience with built-in telemetry and local-first workflows. Smolagents by Hugging Face takes it a step further, pushing for agents that write and execute small snippets of code to solve problems, rather than just predicting text. This shift toward simplicity is a direct response to the framework fatigue of 2024 and 2025. Sometimes less is more, but is less enough for a complex enterprise workflow with hundreds of tools and strict compliance requirements? The answer depends on how much architectural debt you are willing to ignore in the first 6 months of your project. The most dangerous phrase in AI development is "it was so easy to set up." Frameworks that offer a one-liner to launch a multi-agent team are often borrowing against your future stability. This is what I call framework-induced architectural debt. By the time you realize that your chosen framework can't handle long-running transactions, doesn't support proper audit logging, or lacks a path for manual intervention, you've already built your core business logic into its proprietary structures. In 2026, the tier list isn't about which framework is easiest to start with. It's about which one is easiest to scale, debug, and eventually replace. You must choose a foundation that treats the LLM as a component, the entire architecture. Before you commit your team's next 6 months to a framework based on a GitHub star count, you need to see the production scars I've seen. In the next chapter, we are moving beyond the hype to production reality. Check the brutal truth about what happens when these agents hit the real world. In the laboratory, every framework looks like magic, but in production, every single abstraction layer has a price tag. When you use high-level frameworks like AutoGen or CrewAI, you aren't just paying for the final answer, you are paying a framework tax in the form of hidden tokens. These frameworks often inject massive system prompts to manage agent personas and conversation history behind the scenes. In my experience, a simple hello world can consume 10 times more tokens in an autonomous loop than a direct LLM call. If your agent is running hundreds of loops daily, these overhead costs will devour your margins before you even reach scale. We must look at the data, specifically how much management overhead each framework forces into your context window. This isn't just about the API bill, it's about the limited context window you have left for actual data. But tokens are only the bill. The real cost is the time your users wait. Latency is the silent killer of AI applications. When an agent acts sequentially, reasoning, then acting, then observing, then reasoning again, the clock is ticking. In a multi-agent setup, if framework awaits for agent 1 to finish completely before agent 2 starts, your user experience will be measured in minutes, not seconds. Advanced architectures in 2026 demand asynchronous execution and DIG-based parallelism. LangGraph excels here because it treats the agent flow as a state machine where multiple nodes can trigger simultaneously. Conversely, many easy-to-use frameworks default to blocking calls that freeze the entire thread. In high-traffic environments, this creates a massive bottleneck that no amount of vertical scaling can fix. You need to identify which frameworks support streaming and parallel node execution out of the box. This is the difference between a tool that feels snappy and one that feels broken. And if you can't see why it's slow, you can't fix it, which brings us to the observability crisis. If you cannot trace an agent's decision, you cannot deploy it to production, period. Complex multi-agent systems often produce emergent behavior, a polite way of saying they fail in ways you didn't predict. We need deep observability that goes beyond simple logging. You must track the full trace, which agent called which tool, with what exact prompt, and what the raw output was. Frameworks that integrate natively with tools like Langsmith or Arise Phoenix have a massive advantage here. In my years in the field, I've seen teams spend weeks trying to find one prompt injection or one infinite loop that could have been identified in seconds with a proper trace visualization. Look at this checklist. If your chosen framework doesn't support at least 4 of these natively, you're building a black box that will eventually explode in your face. Operational metrics are one thing, but what happens when the agent simply refuses to work? That's where we need a human hand. The human-in-the-loop concept is often misunderstood as just an approval button. In 2026, it means time travel. Imagine an agent makes a mistake in step 3 of a 10-step process. In a traditional script, you have to restart everything. But with state machine frameworks like LangGraph, you can pause, rewind the state to step 3, manually edit the agent's memory or the tool's output, and then resume. This breakpoint capability is non-negotiable for enterprise workflows involving high-stakes decisions like financial transfers or legal drafting. You aren't just checking the work, you are providing a safety net for the LLM's inherent unpredictability. This level of granular control is what separates toys from professional tools. Interrupting is easy, but making the agent recover from its own logic errors is where most architectures crumble. Hallucinations and tool call failures are not bugs in AI agents, they are expected features of the architecture. A production-ready framework must have built-in self-healing mechanisms. When a tool returns an error, does the agent panic and loop forever, or does it reflect on the error and try a different approach? This is the core of the reasoning loop. We map these strategies into 4 categories: simple retries, fallback models, semantic validation, and human escalation. If your framework doesn't allow you to define custom and error edges in your graph, you're stuck with basic try-catch blocks that don't account for the non-deterministic nature of LMMs. You need to architect for failure from day one. Even a self-healing agent is a liability if it has unrestricted access to your internal infrastructure. Enterprise security for agents is a nightmare. Some frameworks like Autogen are designed to allow agents to write and execute code autonomously. While this is powerful, it is a massive security vulnerability in a corporate environment. In the field, we see prompt injection attacks where a user tricks an agent in executing malicious Python scripts that dump environment variables or scan internal networks. To be production ready, you must implement sandbox.code execution, RBAC for tool access, and mandatory output sanitization. You should never, ever let an agent execute code on the host machine. Instead, look for frameworks that support containerized execution by default. Security is the gatekeeper, but where you actually host these agents determines your final uptime and compliance. Finally, we have to talk about where the rubber meets the road, the cloud. Many of these frameworks are built with a local-first mindset, but deploying them at scale requires deep integration with your cloud provider. For instance, if you're on AWS, does the framework play nice with Lambda or ECS? If you're using Azure, can it natively use managed identities for tool authentication? In the Korean market, compatibility with local providers like Naver Cloud or Kao Cloud is often a requirement for data residency. LangGraph's reliance on standard Python makes it flexible, but its state management requires a persistent store like PostgreSQL. CrewAI is easy to Dockerize but harder to manage in a serverless environment. You need to choose a framework that matches your infrastructure's DNA, not just the one with the most GitHub stars. Now that we've seen the brutal reality of production, it's time to rank these frameworks. Next up, the 2026 tier list. Production AI in 2026 isn't about cool demos, it's about state management and deterministic cycles. This is why LangGraph sits alone in S tier. In the field, the biggest failure point for agents is black box behavior. LangGraph solves this by treating the agent as a state machine. It allows developers to define exact transitions between nodes, preventing the infinite looping common in less mature tools. When you are managing complex memory across multiple turns, having a built-in persistence layer like LangGraph's checkpointer is a game changer for fault tolerance. This is currently the only framework that provides the low-level control required to build systems that don't just work once, but work every single time a customer hits the API. It bridges the gap between the flexibility of LLMs and the reliability of traditional backend systems. But wait, if LangGraph is so perfect, why does everyone keep talking about Autogen and OpenAI as the industry leaders? Moving to A tier, we find Microsoft's Autogen and the OpenAI Assistance API. Autogen is a powerhouse for conversational patterns, but it often struggles with autonomy drift where agents diverge from the business logic into endless chatter. In many enterprise R&D departments, teams use Autogen for rapid prototyping because its multi-agent conversation abstraction is unparalleled. However, the lack of a native, strictly typed state machine often leads to unpredictable token consumption. On the other side, OpenAI's Assistance API is the ultimate agent as a service. It handles the heavy lifting of state and file search, but it comes with a heavy tax of vendor lock-in and limited visibility into the brain of the agent. These are excellent choices for high-velocity projects, yet they fall slightly short of S tier due to these architectural constraints. This leads us to a controversial question. Where does the most popular framework for beginners actually land? CrewAI is arguably the most popular framework for builders today, but for enterprise production in 2026, it is firmly in B tier. Why? Because CrewAI prioritizes ease of use over system transparency. It is the classic abstraction trap. While you can get a multi-agent team running in 10 lines of code, debugging a stuck task in a production trace is a nightmare for an architect. In professional environments, we prioritize the ability to intercept and modify the internal state at any point, something CrewAI's high-level task abstractions often obscure. It's perfect for a 48-hour hackathon or a small internal tool, but when you are scaling to millions of requests, that lack of granularity becomes a massive operational liability. You trade long-term maintainability for short-term speed. Is the convenience worth the risk of a black box production failure? Let's look at the frameworks that aren't even ready for that conversation yet. C tier contains the experimental and the rigid. Frameworks like Camel, or very early-stage startups trying to automate the entire dev cycle, currently lack the ecosystem and reliability for serious deployment. Many of these tools are too rigid, forcing you into a specific way of thinking that won't survive a single change in business requirements. In the field, we've seen dozens of these frameworks vanish because they couldn't keep up with the rapid changes in model APIs or the variety of RAG architectures. They are worth watching in a lab setting, but putting them in your 2026 production roadmap is an unnecessary gamble for any architect. Now that we've ranked the players, how do you actually pick one for your specific stack? In the final chapters, we will translate these rankings into a concrete decision matrix that aligns with your specific business goals. Choosing a framework in 2026 isn't about popularity, it's about state control and architectural fit. If your project requires deterministic state transitions and a human-in-the-loop workflow where you can rewind, edit, and resume execution, LangGraph is your primary candidate due to its robust persistence layer and checkpointer mechanism. However, if your goal is rapid prototyping of a collaborative workforce where roles are predefined and you need agents to work in a sequential or hierarchical fashion, CrewAI's high-level orchestration might save you weeks of boilerplate code. For those dealing with autonomous agents that must converse and solve open-ended problems through dynamic multi-party conversation without a fixed graph, Autogen's conversational patterns remain the gold standard. But wait, before you commit, ask yourself, can your team handle the maintenance overhead of these abstractions? Most developers jump into the most complex tool first, but the secret to long-term success is choosing the minimum necessary abstraction level. Picking the framework is only half the battle. Knowing when to use one is where the real seniors shine. But picking the framework is only half the battle. Knowing when to use one is where the real seniors shine. The most dangerous anti-pattern I see in production today is the black box trap. High-level frameworks like CrewAI are great for demos, but when an agent fails in production, you need to see exactly why. If you can't access the raw LLM prompt or the precise trace of the tool call because it's buried under 5 layers of framework-specific classes, you are flying blind. Another red flag is hard-coded prompting, where the instructions for your agent are baked into the framework's configuration rather than managed in a version-controlled prompt registry. I've seen teams waste months trying to migrate from one framework to another simply because their business logic was too tightly coupled with the agent's lifecycle hooks. Always ask, if this framework disappears tomorrow, how much of my code survives? This leads us to a critical realization about modularity, one that most teams ignore until it's too late. Even if you avoid these traps today, the framework you choose might be obsolete by next quarter unless you build it to be replaceable. To survive the 2026 AI landscape, you must design for framework agnosticism. Think your AI agent framework as a driver or an adapter rather than the core of your application. Your business logic, tool definitions, and prompt templates should exist in a pure layer, completely unaware of whether LangGraph or Autogen is executing them. By implementing an agent strategy pattern, you wrap framework-specific code in thin wrappers. This allows you to swap out a LangGraph node for a custom-built state machine if you need more performance, or switch to a lightweight local orchestrator when latency becomes an issue. Consider the prompt logic separation. Treat prompts like configuration files and tools like standalone functions. This decoupling isn't just about safety. It's about the speed of iteration. In my experience, teams that treat the framework as the boss spend 40% of their time debugging framework internals instead of improving agent accuracy. The framework is just a tool to manage the loop. Focus on the observability of your data flow and the human model interaction loop rather than the library's shiny features. Now that we have the decision matrix and the architectural blueprint, it's time to make the call. Let's move to the final chapter for the ultimate verdict on which path you should take for your specific production environment. As we conclude our deep dive into the 2026 agent landscape, the choice is no longer about which library has the most stars on GitHub, but which one provides the strongest engineering guardrails. We have seen that while CrewAI offers the fastest path to a demo, its lack of granular state control often leads to agentic loops that drain tokens without results. In contrast, LangGraph has solidified its position in the S tier for production because it treats agent flows as a deterministic state machine. The three critical factors you must carry forward are state persistence, the ability to interrupt for human feedback, and the native support for cyclic graphs. If your framework treats the agent as a black box where you simply input a prompt and hope for a result, it is a liability in a production environment. Most failures in 2026 stem from non-deterministic tool calling and the inability to roll back state when an LM hallucination occurs. Choosing a framework that prioritizes observability and fine-grained control is the only way to move beyond simple chat bots into reliable, autonomous business logic. But wait, even with the right frameworks selected, how do you actually structure your first 30 days of implementation? Your roadmap to mastering these frameworks starts with a pilot to production mentality. Do not attempt to build a 10-agent swarm on your first day. Instead, focus on mastering the checkpointer mechanisms in LangGraph or the tool definitions in your chosen S-tier library. Ask yourself the hard questions. How do we handle a rate limit error in the middle of a 5-step task? Can we resume the agent's work after a system reboot? If your current choice doesn't have a clear answer for these, you are building on sand. Start by implementing a single agent loop with 100% observability, then scale horizontally. The future of AI engineering is not about writing better prompts. It is about building better systems that can handle the inherent uncertainty of LLMs. As experienced architects, our goal is to minimize the magic and maximize the logic. This marks the end of our series on agent frameworks. By applying the decision matrix we've discussed, you are now equipped to lead your team through the hype and deliver systems that actually survive the first 10,000 requests. Are you ready to stop experimenting and start engineering? The real work begins now as you take these frameworks into the messy, unpredictable world of live production.